So, one of the really cool things that's been happening is I've tried to illustrate a lot of things in the past, from primer pockets to cant to, I mean, those of you who followed this will all know. But the stated goal of this enterprise is to take you along with me while we observe, test, think about the world, to learn to see the world accurately, not trust anybody, learn to test things. I go on the internet all the time. I've spent the last 20 some years, 22, 23 years, with smart people on the internet talking about gun stuff. And one of the things that frustrates me the most is that when something like pressure signs or canting or any of the subjects, cleaning, molly, I could go off. That's not what this is about, though. You'll always have 2 or 3 or 4 or 5 people who seem to have opinions. They seem to, and they're good people, they're nice people, they're all smart people. And the hard part is separating, I've used the term wheat and the chaff. We're trying to separate the facts from the fiction. To do this, we have to see the world free from presuppositions. We have to see the world, and we have to, how do I say this? See it accurately. 2 people can't be right. 2 opposing views can't both be right. And this fart, this is not a fart, by the way, I'm just putting it here to show you so that we can look at it. I'm going to talk again some more about canting. But this fart, there's 2 things that make it, the canting part really cool. Number 1, the separation from the bore line to the scope on the fart is 3.8 inches. I put an AR here because ARs are famous for having a carrying handle and a scope way up, and you get that 3 or 4 inches of separation back here, and the bullet comes up through the line of sight, this being the line of sight. Well, when you can't, of course, that goes crooked. So I thought, you know, I'm going to use an AR and talk about cant because I've been seeing it, I've been fighting it, I've been working on it. I finally realized I can't shoot these things at 100 yards without a level on them. So what I did is I took the old Harold Vaughn method. Harold teaches us to exacerbate the problems, increase the problems. I'll give you an example of that. He wanted to test whether or not bullet nose shape, whether a bent or a crooked bullet would screw up accuracy, BC, whatever. So you don't just go out and start testing bullets. He took some bullets and filed the ends right off of them at an angle so they'd catch air, etc. And went out and tested and measured how they wobble, how they fly, how the accuracy was. So that's what we're trying to do. I'm showing you this cant video this way because I've said before, cant is a huge thing. It's a big thing. And now I'm going to show you, I started running numbers on this 50 fart because it starts so far apart and the trajectory is so loopy on it that it really shows up cant. I'm finding a lot of things that it shows up, and that's why I'm revisiting some of this stuff and saying, hey, this just, it just shows you how it works. And that's so much good. The fart project is subsonic, so let's just call it 1,000 feet per second. When the bullet starts low below the line of sight because of that tremendous disparity, that tremendous distance, that separation between the bore line and the sight line, if it's perfectly level, the bullet leaves the bore, goes right up through the sight line and comes back down on the target. Now, when we start canting this thing at 100 yards, I figured out the offsets and the cant, and I came up with the fact that 10 degrees of cant, 10 degrees is a lot of cant. Let's start with that. I don't know that very many people, I have seen shooters, there's a pro shooter out there that shoots with about 7% of cant, and he sights in for it. It's just the way he holds his AR, or not an AR, but his over-the-course rifle, his cross-the-course rifle, he cants. He brings it into his shoulder in such a way that he twists it in his shoulder pocket, and it works for him. He shoots well, and then we don't have a good way of picturing what's 5% of cant, what's 1% cant. Some of the military training states that at 1,000 yards, a 1% cant will be 6 inches off to the side of the target. And they also talk a little bit about drop, what I would call, I contend, and I showed you this in my other videos, and I told you this in my other videos, that as you cant the gun, the dispersion on the target remains flat. The Marine Corps teaches their snipers that a 1 degree cant, 1 degree of gun cant, at 1,000 yards will move your bullet over 6 inches and drop it a little. Now, running the numbers on that dropping it a little, we find that it's really, really a little. So I contend that it's lost in the noise. I contend that we can ignore any frowny face printing, that as you cant the gun, the load's going to go back and forth. You're going to go get dead flat dispersion left to right. Now, I had to back up a little bit because this silly thing, this fart project, is so loopy and so slow that about 400 yards out, you can start seeing the corners drop off. It doesn't print dead flat. As I was starting to say, when I ran the numbers on cant, my numbers say that 10%, not 10%, a 10 degree cant, 10 degrees of cant, which is not out of line, especially out in the field on a hillside. We live here in mountain country. You can go up, lean against a tree, and be teetering on a rock or sliding down a hillside, and you can't hardly get your feet set. And it's pretty easy to cant your gun. When I ran the numbers, I came up with the fact that 10 degrees of cant would cause 6 inches dispersion to the left or 6 inches of dispersion to the right, depending on which way you canted, at 100 yards. Now I have an RCBS program that allows for it, and they say exactly half of that, which tends to make me believe that I'm right and the engineer for the RCBS program is a pusshead. And I'll tell you one of the reasons I can say that. I'll see if I can get this into the camera. I called the man at his home. We're going to do this differently. I'm going to call this a top view. This is a gun back here, and it fires a bullet through the air. This is the bullet traveling through the air to a target, which is right here. Now, the old RCBS program figured from the muzzle, this being the gun muzzle, a 10-mile-an-hour crosswind would deflect the bullet over X amount. Let's say it deflected the bullet 15 inches at whatever yardage. That was beautiful and perfect and usable. I sold a lot of RCBS programs to people. I told them this is the best, cheapest thing you can get. You type in 10-mile-an-hour crosswind, and it says it moves the bullet 15 inches. Well, that software got old. The RCBS program got updated, and the guy made a bunch of changes on the program, or I ordered a brand new one. One of the changes he made was that he no longer maps wind drift like this. Now he's made it a function of how far do you have to dial off to hit. You have to draw out your trajectory like this. He says that in a 10-mile-an-hour crosswind you have to allow XMOA. Well, I'm sorry. That's bullshit. It's such bullshit that I called the man at his office. We never talked person to person because he got really arrogant on me and basically told me I was an ass and why would I even just learn how to do it this way. Well, there's no way in the field to learn how to do it this way. The guy's obviously never fired a gun in his life. What a dork. If you're firing at a target and a 10-mile-an-hour crosswind comes along, boom, it's going to move it over here. Hey, now we have something we can work with. But if we're firing at a target and a 10-mile crosswind comes along and the program tells us we got to dial over to some mystical place over here and hope that the bullet's going to... Bullshit. So, even though I didn't talk to him, we did send a few voicemails back and forth. Yeah, pretty much. I'd call, leave a voicemail, and I got a voicemail back, and I just dropped the whole thing and said, okay, screw you, dude. If you had given us both options, that would be fine. But right now, this thing is stupid. So now I'm thinking about this, and what he might have halved this one, too. I don't know. But let's just say that with 3.8 inches of separation, which could happen on an AR, 10 degrees of cant, and the funny thing is I didn't even figure for the loopy trajectory. But 10 degrees of cant will knock you, if you cant clockwise, it's going to push the bullet. The bullet's going to come up through the line of sight crooked, and it's going to land between 3 and 6 inches to the right of center. Cant back the other way, and it's 3 or 6 inches, depending on who's right. And I'm not going to try to... I'm not very good with math. I'm an idiot. So I don't expect to be right, but I ran my numbers several times, and I checked with somebody else, and we're not sure about that. But 3 to 6 inches, that's still a 6 inches wide group to 8 inches, 10 inches wide, 12 inches wide group, just from canting 10 degrees. Now, again, the reason that it's fun to videotape this stuff is because I can set up a gun that kind of has a tall scope offset. Not like the fart, but it's enough that it's meaningful. And I find that this works better because, let's go back to that RCBS engineer. I deal with literally hundreds of engineers. And they're just a typical cross-section of humanity. If I deal with 50 engineers, I expect to find 3 or 4 that have got a useful brain. Most of them are just trained to crunch numbers. And that's any brand of engineering. I mostly do it in building and in ballistics. And I have asked 3 different engineers the same question and got 3 answers that disagree with each other to the extent that it's laughable. So this separation of fact from fiction, of useful from non-use, because 3 engineers can design, let's say in my case, a retaining wall. And in each case it'll work. One will just be much more expensive than the other, or harder to use, or one will be good, one will be bad. And the way we learn our skill set in the construction industry is we build all these walls and we find out what works and what doesn't, so we prefer certain engineers. Well, in the gun industry we don't really have that, so we have to learn to think. And that's why I say in this video series, you are the smart people. Learn to see it and learn to think. We're going to talk about max loads, how to find it, pressure signs, because I promised you when we went on this journey with the fart that we were going to make some pressure, even though it's a subsonic load. We don't know what kind of powders we want to use. So I'm saying we'll, we're going to probably pop primers, blank primers. We're going to talk about headspace from a different way because this gun has no headspace except what we make. There are no reamers for it. There's no case design. But in this case, talking about the cant, I just wanted to illustrate that as this gets bigger and bigger, I'm seeing it on my targets. I'm seeing the thing walk back and forth. And technically, according to both my figures and according, I'm not going to take this. According to my figures and according to the RCBS program, with the target, a trajectory as loopy as I'm getting with the fart, and the separation as vast as the fart, it's possible as that cant-induced. The numbers show that if I'm 6 or 8 inches over at, say, 150 yards, I could be starting to actually sort out and see the drop-off, which is really, I'm still going to state that cant makes a group shoot flat, don't even allow for, don't even think about. But when that cant gets over 20, 30 inches away, if you're at 1,000 yards and you can run these numbers, it does actually start to show the drop with the fart project. It does actually map that falling off at the edges. But for all intents and purposes, the cant-induced throw to the right or the left is dead flat. But while I've been talking here, the reason I've got this gun jacked up and the reason I'm going through this kind of off camera and letting you look at this gun is if you look at this gun, try to just guess how much cant, is this gun straight up and down? I mean, granted it's in the camera so you can't tell, but cant's not that easy to see. I said 10% is really brutal, but that's not true. I've known, you could go watch this guy that I talked about shooting in a tournament and winning and holding his rifle with 7 degrees of cant, and you will not see it. And I'm not gonna prove anything right now, but I'm gonna show you how easy it is to be fooled. I got fooled out here. I shoot enough that I pretty much feel vertical on the crosshairs, and I'm shooting at a target that has vertical lines on it. But I would find myself, it's so easy on these high separation guns. In my case, the fart. In thousands of other cases, it's the AR situation where you got a scope sitting way up here. It's way too easy to just roll the gun onto the target. Versus jack, 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 jack in a flat line. Screw your rest over, move across your bags, move the back bag around. It's hard to get a gun to naturally sit where you want it. And with this tall separation, it's easy to just go, and you're on target. But it shows up like a monster. I'm shooting at 100 yards, and I'm seeing 2, 3, 4 degree cant. I've been fighting it. I've got a tall target up here behind me. This is where it really showed up. I'm going to see if I can lean it down into the picture, because I don't know that I can, but there's a group there that if I can get it lined up, it's showing way more. I'm running up through a velocity spectrum, and I'm getting a lot of side to side, and it wasn't windy. This tall target is something we'll talk about later. There's all kinds of uses for it. But I realized that I was coming onto the target and I was just rolling the gun over on, and when you roll it over, it's better. I'm trying to train myself from ever again in my life saying trust me, because I don't want you to trust me. I say trust me, it's that much. No, I'm going to show you. I'm learning more and more that passing on evidence is about showing the evidence. So this gun right here is just sitting here, and if I just randomly put it in, and I have a device here that we use in the construction industry. It's an angle finder, and one of the things we can use it for is setting stair treads so that we get some batter or some pitch or some tipper, or this is even long enough, we can use it to set the pitch on a sidewalk, to put a 2% or a 2 degree. So what I'm going to do is, we've looked at this here and we can say, oh, it's got 1 degree of cant, it's flat, it's got 5 degrees of cant, maybe it's got 10. No, it doesn't have 10. But, check this out. Let's see where we're at here. Well no, let's get it squared up a little bit. I got that downward at 4.7. This is essentially 5% cant here, guys. Let me really get up on it. this a little better. 5.2. It's angled down a little bit, so I have to set it square to get an accurate reading. So work with me here a little bit. But let's just say that's 5 degrees of cant. It's not very apparent is the point. 10 degrees of cant, I first said, that's so huge you never run across it. Simply not true. Out in the real world, it's entirely possible to get 10 degrees of cant into your system if you're in a balled up enough situation, going downhill especially. I left this at a little bit of an angle because, well, mainly to line up with the camera so that you couldn't see the cant. But this separation thing really points out the fact that cant is not a negligible thing, and that cant, in this case, between the low velocity and the scope separation, I'm seeing tremendous effects at 100 yards. And enough that I wanted to make this extra cant video to add on to my other ones, to say, you AR guys in particular that have got a tall mounted scope, go out there and lean the gun when you have a good load and see for yourself. Cant is a big deal, and hopefully this helped to illustrate that. If not, I apologize.